Section 1.3, Data Collection and Experimental Design. When we collect information and classify it as data to further research, there are two methodologies we use. There's observational and there's experimental. Observational is simply observing what is going on, and we do not affect anything that we're observing. For example, if you sat on top of this building and wanted to see what doors people come in, you wouldn't do any part of it. You wouldn't interfere. You wouldn't lock certain doors and see which other doors they go to. You just want to see what doors people are coming in. You're observing. We don't interfere at all. We have no control of anything of the subjects going in and out. We're just going to record the information. Here's an example of observational information that we observed. I'm looking at the different age ranges of people who use Facebook. Well, in age 18 to 29, 70% of people use Facebook. 30 to 49, 77%. Age 50 to 64, 73%. 65 plus, 50%. I do the same thing with TikTok users and Snapchat users. And this is actual data that I downloaded. Really what we're looking at here is we're not affecting how they're going to Facebook or TikTok. We're just observing. We're collecting information by asking people, where do you go to? Another observational study you often see in the medical realm is looking at the randomized data and then seeing what happens when the data is interacted with other aspects. You don't affect it at all. One of the greatest examples of this was about 100 years ago. Doctors were observing prisoners in the United States were not getting as sick as the general population. And they started tracking what they were doing. Why weren't they getting sick? They were not given that good of food. Well, one of the things they observed is they were given moldy bread. They weren't given fresh bread. And the prisoners were hungry, so they ate it. The moldy bread grew penicillin on it. And this is where penicillin comes from. They observed that they didn't get a lot of illnesses or diseases because they were taking the first antibiotic. To this day, this is how penicillin and the various aspects of penicillin are grown. And we observe simply someone sick, they give them the moldy bread, and that person got well. Observational studies are also used to look at rare events that we see something's happening we didn't realize, and we want to see if there is some kind of interaction. Now, this goes to what we're talking about towards the end of the semester, where correlation is not causation. One does not cause the other, but it does bring further research that should be done. One example of this is looking at in states where they've legalized marijuana for recreational use, they have lower opioid overdose deaths. Does this mean people are using marijuana instead of opioids such as hydrocodone, OxyContin, and other dangerous class 4 drugs? We don't know. But there is an observation here. There does seem to be some interaction, again, bearing further research. It also helps us look and just observing for real life situations. I got a picture of Play-Doh here. And the reason I show Play-Doh here is about 100 years ago also, most people did not have electric or gas HVAC systems. They had coal. That coal creates soot everywhere. And what people do, they would purchase this large container of this gray material and push it up against the walls to remove the soot. Well, once HVAC systems had natural gas and or electric, they weren't using coal. So there's less soot. The companies making this material that removed the soot were going out of business. What a product manager realizes, we discolor it. We can resell it now as something different. A toy, Play-Doh. And that's how Play-Doh was created. This is a prime example of observing people using products for other purposes than they were originally intended. And we don't interact with this, we just observe it. As opposed to observational studies, there's experimental studies. This is where we interact with the experiment and see what happens between one group and another. We do manipulate it to see if there is a significant difference. And this is the basis of statistics, to see statistically how different it is or it is not. Again, medical world uses a lot of this information. Suppose we have people who have headaches, and we give group A an aspirin. Group B, we give a placebo, a sugar pill. Hopefully, the people in group A, their headaches go away either much faster or much greater rate or much more quickly than group B. This is how we prove there's a significant difference. We're going to be studying this semester at what level do we determine it is significantly different. But people do not know if they're in group A or group B. We're talking about blind and double-blind studies in a moment here. So they don't know if they're taking the placebo or the headache, so they cannot affect the outcome. The treatment group, this is also known as the experimental group. This would be group A, the people taking the aspirin. The control group are the people not taking the aspirin. We want to see if there is a difference, and we're going to talk about statistically how to determine if there's a difference throughout this semester. One of the things we've got to look at is the ethics behind this. Having a headache, that's not that major of a malady. We wouldn't do this for a cancer patient. We wouldn't give 50 cancer patients the cancer drug we're testing and the other ones no cancer drug. Often they do something like they'll use a current cancer drug and an experimental cancer drug to see if there is a significant difference. Experimental units. These are the individuals or groups that we're looking at. If we have 1,000 people, 500 in group A for the headache medicine, 500 group B for the placebo, our experimental units are the human beings, and there's 1,000 of them. A simulation. A simulation is used as a past experiment for the greater projection of what it could be. We learn where the problems are. These are often computer-based, and if we can do it on a small board or a computer, we can then preface it with, this is what we're going to see in the entire actual situation here. For example, if I want to know a 6-sided die, what number comes up, and each one of those little dots on each side of the die called a pip. Which pip comes up? Well, if I roll it 6 times, probability-wise, each one should come up once, but there's no guarantee. I should have a 1 come up once, theoretically, a 2 come up once, 3 pips, 4 pips, 5 pips, 6 pips, each come up one time. But we would roll this, and I have the roll order. The first roll, it'll be either 1 pip, 2 pips, all the way through 6 pips. Second roll, third roll. And we could see, do we get 1 equally out of 6 rolls? Or is there like 2 on the first roll and second roll, 2 pips? And then the third roll and fourth roll, 6 pips. So, and maybe the more we do this, the more it balances out. But this is a simulation. This shows the real life of what's going on. It's usually much less expensive and quicker and easier to do to let us know where the problems may be. The advantage of simulations, you can avoid danger if you're doing major aspects of it. We can move the conditions quickly. It's also cost effective because we're not using a huge group. We're doing a small computer simulation or a small group, for example. However, the disadvantages of we don't know the interactions of real life situations. When we're controlling it as a simulation, we're controlling everything. We don't know what's going to happen one way or another. For example, if we had a simulation for the aspirin versus the placebo, we can't control people watching television and seeing a commercial or reading something on social media a different way to get rid of a headache. One of the most powerful situations, and you can look this up, I've got the link right here, is the Milgram Experiment. In the late 1950s, Stanley Milgram, who was a social scientist, had 20 students come in one at a time individually. And they're paying the student, and they sat on this table, and there is an enclosed wall. On the other side, there's a person. And they were supposed to shock that person with like 5 volts or 10 volts. And the experimenter would tell them, okay, bring up 10 volts, shock them. Bring up to 15 volts, I'll shock them. Not 20 volts. Kept bringing up higher and higher. And they couldn't see the person, but they could hear the other person. Once they got to 60 or 70 volts, sometimes the people on the other side of the wall would start screaming. And the experimenter keeps saying, okay, go up higher, keep doing this, go up higher, to see how high a shock someone could stand. Well, this was not the experiment. The real experiment was to determine how far someone would go when they're being told to do something. He did this because he wanted to know, how did so many intelligent, smart people fall for Adolf Hitler in World War II? Why did they keep doing these things? No one was really being shocked. There's an actor on the other side. But the students who were doing this didn't know this. And it's been done many times. But the interesting thing about the simulation is much safer than the real world of doing something terrible or evil and see how many people follow. When this experiment was repeated multiple times over the years, you usually only get about 5 to 10% of all people say, I'm not doing this more. This is wrong. After they got to 40, 50 volts, hearing someone scream or hearing someone, what they thought was falling over, and the experimenter comes down and do it, they'd say, I'm not doing this. I'm done. I don't care if you pay me or not. Powerful simulation, one of the most famous ones. Milgram Experiment. Look it up. Absolutely fascinating. When we do more traditional surveys, there are advantages and disadvantages to each type. The personal survey. You can ask questions one-on-one with someone. You can show them things. And when you stop someone in the street or in the mall or wherever you get it, you can get high response rates, especially if you're friendly and open-minded with them. Disadvantage is very expensive and it's very inefficient. You may only be able to talk to 7 or 8 people an hour, if that much. The telephone, you can talk to more people quickly. It's less expensive than paying someone in person. You also get a high response rate. However, it's very difficult to get someone to listen to you and trust you over the phone when they're a perfect stranger, especially when you call them at dinner or at lunch or an inconvenient time. A lot of surveys are done through the mail. You can target a huge amount with a small group. You can also put some information there visually so they can see it. The response rate, though, and this is from also I've seen this firsthand, is about 1.5%. So for every 100 pieces of mail you get, you might get 1 to 2 responses for a survey. Same electronic with the internet and social media. You can get to millions of people quickly. But in addition to a low response rate, because a lot of people aren't going to do a survey, you're going to have people who you're not even trying to target often respond to it, which is not going to help your data either. Now, experimental design determines how we're going to do the experiment in the first place and control as best we can. Repeated measures, do we have independent groups? And I'm going to show you these in a moment here. Most common way is actually divide in 2 groups. One gets a placebo and one gets the actual medicine, or one is experimental, one's a control group. There is a confounding variable. An example of that I gave a little while ago is they may take a placebo, some people, the other may take the aspirin. We don't know how many people are watching TV and being affected by some program that says if you lay down, put ice pack on your head, your headache will go away. Well, that would confound it because we weren't planning on that. The placebo effect is this determines if having a placebo or nothing does show a difference. There's also blinding or double blinding. I'm going to show you double blinding in a second here. Blinding means the people don't know they're being experimented on, or who is the experimentee and who gets the placebo. Double blind means the person administering also doesn't know. For example, a double blind study works in the way that someone gets a medicine, a doctor prescribes it. Only the researcher knows who gets what, usually by some code. The doctor who does not know if a patient is getting the placebo or the pill because the medicine is blinded, is masked. Not just literally, but figuratively. and the patient doesn't know. So it's blind to the doctor, blind to the patient. They don't know if they're getting the medicine or the placebo. And this determines, with the true control, is there a statistical difference? Now, you also want to be random with your people. You don't want a group of people who are all very similar. You want to try to be as random as possible. We can do them in blocks. For example, if we want to do some kind of experiment where for a television commercial to say, well, how do people act against it? How do they feel about this? We might say women may act different than men. We separate the men, women, men, and then we randomly pick different people among the women, different people among the men, and we compare the reactions. That's blocking it. The one block is females, one block is males. Matched pair. I got some social media examples here. Who, test for more social media, by the way, is used on smartphones than they are on computers now. That shouldn't surprise anyone here. We want to know if there's a difference in what smartphone types they're using for social media, by ages 18 to 30. I'm picking 10 users who are Android, 10 users who are iPhone, 10 users who are Windows, 10 users who are Amazon Fire. Each one has the same amount, and we're going to match them all. Make sure there are 10 users in these age group, be 40 in each group, but we're matching them all. These are matched pairs. Simple random sample. We got a population here. We just randomly pick any people or any individuals within that. I just randomly pick 3 out of 12 within the population. Stratified sample. We may have separate groups. We pick one from each group in this case, for example. We have subgroup 1, subgroup 2, subgroup 3. We may pick, we want to do some kind of political poll. Well, we're going to pick 10 people from Georgia, 10 people from Alabama randomly, and 10 people from Tennessee. Each subgroup is a state in this instance. Cluster samples. These are the least trustworthy in my mind. Cluster sample basically says that, okay, we've got all these different subgroups, but we're only going to pick several from a couple groups. These could be 5 states. We're only going to pick 2 states. And the reason we do this is it's more economical, but we're making the assumption what happens in one state if we pick random individuals, is the same as what happens in another state. So there is questions on how we should do this. Systematic sample, this is where we have a system. We pick every third one in this case. Every 3, the 6, the 9, the 12. We have a group of people. We pick every 5th one, 8th one, 12th one. There's a system behind it. Then a convenience sample is probably the least trustworthy of all. I got a speaker here. If he was doing a survey, he picked the most convenient people to talk to, the 5 closest to him in the audience. I'm not sure that's very random. I'm not sure it's very accurate. But that is what this person is doing, and a convenience sample is saying, I'll go talk to all the people in the office to see if it's true or not. Who likes what?